Hello, it's Kev Randall. We're continuing with the June 2007 OCR paper. So we've got June 2007, it's a Core1 paper, question 8. This question involves completing the square, and we use the completed square version to find the vertex of the curve, and then we solve an inequality. So first of all, if we recall that to complete the square, if we have an expression such as ax squared plus bx plus c, then to complete the square we can say x plus b over 2 all squared, minus b squared over 4. Well, b squared over 4 is b over 2 all squared. It's a simpler way of putting it, plus the constant term. So that's the completed square version. So if we apply that now to the expression that we're given, so we apply that and we get x plus b over 2. Well, b over 2, b is, in our case, b is 8. So b over 2 is 4. That's all squared. Minus b squared is 8 squared, which is 64, divided by 4, which is 16. Plus c, which is plus 15, which we're given. So the completed square is x plus 4 all squared minus 16 plus 15 is minus 1. So that's the first section. So for doing that, section 1, we get 3 marks. Part 2, it says hence state the coordinates of the vertex of the curve y equals x squared plus 8x plus 15. Well, when it says state, in an exam paper, when it says state, you shouldn't have to calculate anything, you should just see it. So what we do, for the x coordinate, we change the sign, so the coordinates are minus 4 and minus 1. And we get 2 marks for that. Again, when it says state, if you find yourself having 2 calculations, you're probably doing something wrong. Because state means exactly what it says, just by inspection. Then question 3, part 3, says solve the inequality x squared plus 8x plus 15 equals 0. Is greater than 0, sorry. So we've got this expression now. We've already expressed this in a different form here, there, so we can now say x plus 4 all squared minus 1 is greater than 0. And rearranging that, we can get x plus 4 all squared is greater than 1. Now if we go ahead to solve that as we would solve a quadratic, we take the root of both sides. We've got x plus 4 is greater than plus or minus 1. Just if we try and imagine that in terms of a graph, we've got a quadratic graph something like that. We've got 2 roots here, there and there. Just to explain this, what we're looking for is when these values, and the value of this expression is greater than 0. Yeah. So we're looking for that and that. So if we just rearrange this, we get that x is less than minus 1 minus 4, which gives us x is less than minus 5. The reason we've gone from a greater than sign to a less than sign is because of the negative. So that is here. So if we say that would be minus 5, then we can say x is greater than plus 1 minus 4, so x is greater than minus 3. So that value there is minus 3. So that solves that inequality. And we get 4 marks for that. So thanks for watching. Look for the rest of the examples in this paper and more papers in the series.